Today I would like to talk about isolated components-driven development. If you don't know what the heck this is, or what the heck talk this is, don't worry. I will cover basically what they are, why and when should you use this approach. It's not a comprehensive presentation, so I won't talk. I won't go into the details of how to implement this. But yeah, let's see how this goes. Before I begin, my name is Andrei Pfeiffer. As Anna mentioned, I'm a code designer at Espresso, focused on front-end technologies and UI development, web and mobile. I also write technical articles on Medium from time to time, mostly about React Native and JavaScript in general. And I'm also the organizer of tim.js, which is the local JavaScript meetup in Timisoara, and the revo.js conference, which is a new event that's going to take place in Timisoara later this year in October. By the way, how many of you have heard of revo.js? Please. Oh, okay, so not quite half. So let us spread the word, please, so we get the whole room know about this conference. And if you are interested in JavaScript ecosystem in general, I welcome you to join both the meetup, the tim.js meetup, and the revo.js conference. Okay, so this is what a typical web application looks like. You have a UI that's connected to an API, and the API usually gets the data from a database. Right? I think probably most of us worked in a simple architecture like this before. When you are developing user interfaces, you need to see how certain components look with, I don't know, let's say with one item, or with multiple items, or with no items at all. So you usually have a feature to write some data into the database in order to extract it and to see how it looks on the screen, right? Well, not all UIs have this feature to actually be able to write data into the database to see what they look like on the screen. There are some UIs that receive the data from an external source. And this type of applications or this type of UIs are a bit difficult to develop from one point of view, because you cannot control like what do you see on the screen, right? Because the data comes from somewhere else. You have no way to mock or to add some dummy data in order to see the result on the screen. Think about Google Analytics or GitHub, for instance, right? Where the data that you see on the UI, it's not the front-end developer that can easily control like what data to test with when developing the components in the UI, because the data comes from a separate source. That's the same with GitHub. It's very difficult to control this data. So keep this in mind. So how do we connect our UI to the API? Well, during my experience, I've tried 3 different ways to connect the UI to the API and to the database. So one solution would be to connect to a remote development server. So the backend engineers, they deploy the application to a development server, and you connect your UI directly to that server. This has a few benefits, because you don't need to do any local setup. So for me as a UI developer, I don't want to care about setting up servers locally and virtual machines and all that kind of stuff. So for me, it's like a real benefit. Also, you get to share the data or the state of your application, because if you have multiple members of the team, if I want to send another team member a specific state or to reproduce a bug or a situation that I have, it's very easy because we all share the same state of the application. So it's very easy to reproduce certain scenarios. However, you depend on the infrastructure, because usually you deploy like one certain branch on your development server, mainly the develop branch. But what do you do when you need to test a feature branch, for instance, or you want to test a feature branch and a colleague of yours wants to test another feature branch? So you need to scale up this infrastructure. You need to have separate development servers and to deploy different branches to different servers. So this is not trivial to manage. Also, it only works online. You need to have this internet connection in order to connect to the development server, right? So you cannot work offline. You cannot work from, I don't know, somewhere remotely when you don't have a connection. Now, the second approach would be to have to install all the system locally on your machine. Of course, it works offline. You don't need any internet connection for this. It's great because you can easily switch branches, so you can test out different features that are developed on the API on your local machine, which is really great. But it's very difficult, not very difficult, but not trivial to sync the data with other team members. So if I would like to show you like a specific state that my application is in, and I want you to reproduce it to see, well, is it not working on my machine, or is it not working on your machine as well? So I would need to basically export the database, send it over to you or over email or Slack or whatever communication channel, and then you would have to import the database on your local machine, and so it's not a trivial process. Also, you need to perform this system setup or migrations of the database. Now, with the Docker and Docker Compose, lately, this got easier and easier, right? You usually run one command in the CLI, and you have all your system up and running on your local machine. But that's rarely the case. Like, it's not all the time that works like out of the box with one command. You have to do some adjustments on your system, because every system is different. You have Mac, you have Linux, Windows, so it's not very trivial in this regard. Also, you have to take care of migration, so it's an overhead that you have to deal with. Now, the third approach would be to have a fake server, or I don't know how to call it, fake server, fake API, I don't know. The idea is that you have a proxy server that intercepts your request to the API, and then you just return some stubs data or some mock data, right? You don't rely on the real API. This also has several advantages. All works offline. You can very easily stub any data you want, because you just tell the fake server like what data do you want to return. However, you have to deal with the schema updates of the real API, right? Right now you have two APIs. You have the real API and your fake API, and your fake API mimics the real API. And whenever something changes in the real API, database schema or whatever the structure of the endpoints is that they return, you have to manually update it in your fake API as well. So you have to deal with this kind of issues. So in an ideal situation, when we are developing user interfaces, we want to focus on the UI. We don't want, I personally don't want to care about setting up the API in the database in an ideal situation. Let's go a bit deeper into this UI. So consider a component hierarchy, like this one here, but consider it like much more complex than this, not only these, I don't know, 7 elements that I have. So I have a root component, an entry point into the application, and some routes. Now each route usually takes some data from an API, fetches the data from an API, passes it down to other components, which in turn could fetch other data to other API endpoints or to third-party services. And let's consider that we have to add a new component somewhere deeply nested into our application, or to update an existing component. Consider having a button that when we click it, it opens a model with an image, so like a view screenshot button. Now, remember what Cesar said previously about the banana and the gorilla in the jungle, right? So we have the banana there, so we want to, only the banana, we want to touch the button to add a new component into our entire application. But we also need to start the entire application, the gorilla, and that comes with a dependency on APIs and third-party services, so with the entire jungle, right? So we don't really need to have all these dependencies and all this overhead in order to, I don't know, work on a freaking small component, right, in our application. Because what we want to do is basically render a simple component like a model. So if we could take this component and develop it like somewhere else, to not rely on the entire application to be started and the rest of the APIs, wow, it would be great. Because in this way, so if you render the components outside the application, we can just not care about anything else, and we can pass it, we can test our different scenarios to pass in different data in different combinations to the same component, and we could very much easier develop it or change it or to test or to reproduce specific bugs that we need to. And if you think about it, this is just like unit testing. Like when you do unit testing, you take a function and you call it outside the entire application, entire system. Or you take one class and instantiate it and test it if it runs outside the application, right? So we want to achieve the same thing, but with UI components, right? We don't need the entire application, the entire APIs, just to do UI components development. So I have worked with two different solutions to these two different tools, Storybook and React Style Guidist. Storybook is, they say about itself that it's an open source tool for developing UI components in isolation, while React Style Guidist is an isolated React component development environment with a living style guide. Now, as the name implies, React Style Guidist is only for React. Storybook, you can use it with any framework that you want. But they are very different in into how they achieve this isolating development type of thing. And we're gonna go a bit deeper into the differences between them. So probably you don't see until all the way to the back. This is, I'm gonna go very briefly to how to define the stories. You can find their documentation is like really good. You can find all the examples in their documentation. I will go very briefly to highlight some differences. So in Storybook, you define so-called stories into JavaScript files that are stored outside your components folder. So you store them somewhere in a .storybook folder outside the components folder. You have some boilerplate code. You import React or Angular or whatever framework you are using, and import these stories of React. You import your component that you want to render, and then you have some specific API specific for Storybook. You say Storybook components. You add different component model, and here you just specify like how do you want your component to render, with what props, with what state, in what combination you want it to render, and you write JavaScript files. So basically, you can do anything you want because it's a JavaScript file. In React Style Guidist, you write markdown files, and usually these markdown files are stored next to your components. So where you have your components, your source file, next to it you have this markdown file that defines how do you want to render this component. And it's just markdown, and you write in a comment block, you write the same thing that you write in Storybook. How do you want your components to render? Now I will show you very quickly like what does this give you. So with the Storybook, it starts a local development server. So local host, you get a port, and you get this UI, and these are the two buttons that I specified in my JavaScript files. So we have the same button with two different states, one loading state, and it renders it on the screen, and you get the second component, the second button with the model with an image displayed. So you can write like it's your choice to write any combinations of props that you want, but this is like a very basic UI. You don't get anything else out of the box with the Storybook. There are plenty of plugins that enable you to add additional functionality to this UI, but yeah, out of the box, this is what you get. Now with the React Style Guidist, you get a similar UI. You have the same buttons here. Click them, they work the same, but you get something else out of the box here. You get these props and methods, like all the props that you define on your component in your source file. It gets parsed by React Style Guidist, and you see like the list of all the props with the type, with the name, the type, the default value. And you can also add additional description in order to, I don't know, get some better understanding of what that prop is used to. You also get this view code here. So this is the code that renders these components here. So the cool part is that this is you can control the whatever you are editing here, it gets reflected into the rendered component, right? So you can try out different scenarios or different combinations of props. Only you don't have to go to the source code in order to do that. With the Storybook, you can get these features using additional plugins, right? So you can have the same functionality in Storybook as well, but you need additional plugins. You also get a lot of other plugins, official ones and community plugins, and also you can write your own plugins as well. So, brief comparison between the two. So as I said, React Style Guide is only for React. Storybook, it has integrations for any framework that you might use today, and probably tomorrow as well. Storybook has a plugin system. React Style Guide it doesn't. They had the plan to introduce one, but it's very complicated, so they dropped it. But as I said, Storybook has a lot of plugins. Now, you can check out the list of plugins on their website. One of the cool plugins, I would say, is one that automatically renders all kinds of possible combinations between different props for one component. So you don't have to manually output all the to define all the possible combinations. There is a plugin that that does that for you, and all kinds of different ones as well. How you write examples is very different. With the Storybook, you write them in JavaScript. With React Style Guides, you write them in Markdown. This comes with a huge differences between the two of them, because in Markdown you only write sort of static or declarative syntax. You have no logic there. So the source code or the Markdown file is very easy to read and also very easy to write, but it's not very flexible because you cannot do a bunch of stuff like adding logic to it. In Storybook, because it uses JavaScript to define these examples, you can do whatever you can do in a JavaScript in a programming language. So you have much more flexibility, but it can obscure the code or the intent of what you are writing, because you are able to write like complex logic there. So there's a big difference between the two. And also, because of the way you write examples, the main purpose of the two solutions are very different. For Storybook, the main purpose is development. So use it as a tool to develop, or to use it only in development for your UI components. On the other hand, React Style Guidist, its main purpose is documentation. So how to document your components, or how to write a UI that's publishable on the web, or especially for open source or component libraries, to be able to see like what are the components available for one application. So you can do both development and documentation with both solutions, so that's not an issue. But you can see that if React Style Guide is much more inclined to documentation, because you can customize the UI, how it looks, what the output is. You can customize it very well. For Storybook, you cannot do that, right? There is no way in the documentation how to do that, like how the output looks like. Also, because of the plugins, which you don't get in React Style Guidist, well, you don't get any additional benefits than what it offers out of the box. So you cannot extend it, you cannot add additional functionality. With Storybook, you can add all the plugins, and it's very, makes the development much easier. So how would you adopt this type of approach to your existing project? Because you don't have to go all in with it. The first step will be to use it locally on your machine. So just install it locally on your machine, try it out with different components. You don't have to commit the entire thing to the main repository. You can have it run only locally on your computer. You can try out, for instance, Storybook. Other colleague can try out React Style Guidist if we talk about React project. And use it when needed. Like, when would you need it? Well, when you feel that it's very difficult you need to start the entire gorilla and jungle, kind of thing, only to do a small update to one component, or to create a new component. When you feel that this gets in the way, then probably a solution would be to think about this approach and to develop the components in isolation. The next step will be to share it with the team, right? To commit everything, to check in the repo, and everything. All the team members have access to the same environment and to the same examples to see how or what components are available in our application from a development point of view. How do you use the components? Because you can have different the examples with different inputs, so you can see. You can basically also document it internally for your team. But you can also publish it online. Like you can create a static build using both Storybook and React Style Guidist, and you can publish it online, so you don't have to clone the repo and run the development server only to see like what are the components available in our application. You can publish it online. You can always check it out. And this is probably one of the main reasons why this approach works really well for component libraries or style guides. Because when you are developing a component library, like you don't have an application to actually put your components in, right? So you have to have some sort of environment in development in order to be able to develop the freaky components. So this is ideal if you are doing component libraries. You can find me on GitHub, Twitter, Medium. I don't do Facebook. If you have any questions, please feel free to ask me. I worked with both libraries on 3 different projects, so I have enough experience, I think. So thank you very much.